다음으로 두 번째 발표는 스마트 도시와 공간 빅데이터라는 내용으로 일본 동경대학교 공간정보과학연구센터 아키야마 유키 교수님께서 발표해 주시겠습니다. 큰 박수로 맞이해주시기 바랍니다.
오케이, 안녕하세요. 전 백기승입니다. 제 이름은 아키야마 유키라고 합니다. 잘 부탁합니다. So now I'd like to talk about my today's presentation. So today I'd like to talk about the smart city and the spatial big data, about the studies and cases in Japan. I'm Yuki Akiyama from the University of Tokyo. So first I'd like to talk about my self-introduction. My name is Yuki Akiyama and my birthplace is Okayama City. Okayama City is between Tokyo and Seoul. And my main field is spatial science and engineering and geography and so on. And my affiliation is assistant professor of the University of Tokyo, the Center for Spatial Information Science. And from last year, I'm in the visiting research fellow in the Korea Research Institute for the Human Settlement. And basically my original major is architecture, and but my graduate thesis is about urban hinterland. So after the graduated the university, my interest moved to the GIS and smart city and so on. Okay. So now there are many problems in urban areas. So now I show you the example of the urban problem in Japan. For example, declined city center, aging, traffic management, disaster, and increasing of the vacant houses and so on. So to resolve such kind of problems, to design the urban planning and to realize smart city is very important. And to realize such kind of the urban planning and to realize smart city, to use many kind of the geospatial data, and the census data is very useful, and they can support to resolve such kind of problems. So actually, recently we can use many kind of the geospatial data like this, the map in the web map and the car navigation system, and where the map from the smartphones. And this is also the kind of the geospatial information services, the Pokemon Go. So I also installed the Pokemon Go. Yes. So fortunately, I can get the Pikachu yesterday in Tokyo. Okay, so now we can use such kind of building data and the household scale data, and finally we can also use the person scale data. So in Japan, we call such kind of big data with the location and time of the geodata called the micro geodata. Actually, the many components is related to the micro geodata. For example, the last year I joined this conference. This conference, basically this conference is urban planning or urban management. But there are some sections. For example, here the big data visualization and so on. And this year I joined this conference in ISPLS. This conference is basically in remote sensing, but the conference contains some kind of the big data for the big data visualization or the processing. Okay. And in addition, the Japanese government began to develop the legislation toward the promotion of the utilization of the geobig data and the micro geodata. For example, this news said the Japanese government is developing the legislation to use big data to conceal personal information without others' consent. And in addition, recently the Japanese cabinet office is developing the research in the regional economic society analytic system, which is visualize the various census data, the big data for the Japanese local government. So recently we can use many kinds of the spatial data and the big data. So the widespread use of the detailed data map to create the demand for the detailed detailed geospatial data. So recently the micro geodata is gathering attention. How to develop and share and apply for the realization of the smart city with the micro geodata. So that today I'd like to talk about the three topics. First one is the brief introduction of the available microcontroller data in Japan for the learning. And second, I show you the three examples of the studies, the case studies in the to utilize the microcontroller data. First one is the personal microcontroller data utilization. The second is the disaster big data, and the third is the public big data. And finally, I explain the summary and the future works. So first I show you, I explain the microcontroller data in Japan briefly. For example, first one is the realization map, the telephone directory. And to use this map, we can monitor all locations of the building, the road, the rivers, and so on. And this is also we can monitor the location of the commercial areas. And this is the new data. This is the enterprise transaction big data. This data contains all locations of the companies, of the enterprises. And the transaction information is also included. And the weight information is also very interesting and useful data. This is because this data contains the geotag. And to integrate such kind of data to the spatial temporary, we can also develop the time series data like this. And the next is the microcontroller data of the person and the person distribution of the flows. For example, the person flow data is developed in the University of Tokyo. And this is the various mobile sensors data based on the GPS or the CTL data from the mobile phone. And this is the new data. This data is the personal flow data based on the SNS tweet with the geotags developed by the private company in Japan. And this is another data. It's the micropopulation sensors where we can monitor the location of the residential population throughout Japan. Okay, so now I explained about the example of the study or the cases to utilize the microcontroller data. The first one is utilize the personal microcontroller data. So recently the various sensors data can download to utilize recently, and especially the population sensors is used as the base data to understand the distribution of the population. For example, the urban planning, the traffic planning, and so on. But more detailed, reliable population data are required to resolve these problems that are smarter than before. So how to monitor the detailed population distribution? So this is the answer. The first one, the residential population can monitor the micro population sensors, and the dynamic population can monitor the mobile phone data. At first, I show you the micro population sensors. So this is this point shows the distribution of the residential, the household locations. And this data contains the detailed information about each household information. So how many people live, or the age, and the gender, and so on. Okay. And this data can cover throughout Japan. Like this. Such kind of the city block data. And this is the aging rate. Okay. So this data can cover throughout Japan. And next I show you the dynamic population by the mobile phone data. So now the almost all people have the mobile phone. So if you have the smartphone, please raise your hand. Smartphone. Yes. So this is the answer. So almost all people have mobile phone, the smartphone. And many mobile phones have the GPS function. So the study to monitor the dynamic population using mass mobile phone GPS data is now the constant attention. So for resolve the various other problems. Okay. So this is the example of the United States. So this map shows the characteristics of each road based on the dynamic population. So this map shows the road characteristics and the spatial temporally. And another example is this is a very interesting example in Kenya. So the 3/4 of Kenyans use the mobile phones now. So the mobile phone GPS data are used for the animal quarantine. So when the livestock disease occurs, this information is shared all the application users. And based on this data, maybe I'm able to move the safety areas, the safety district, and this is the example of the Japanese the mobile phone data. This data called the congestion analysis, and this map shows the population, the dynamic population, and this map is updated every hour. So this is the same real-time maps, and in addition you can see this result with the free. There are some problems in the movie. So now I show you the mobile GPS data, GPS log data. This map shows the date of the Great East Japan earthquake in 2011. So that all the points shows the move of each mobile phone users. But this is not all users. This is only about the 1.5 million persons in Japan. Now the Olympic persons can move. This is because before the earthquake occurs. And the earthquake occurred in 246. So now it is normal. But after 246, almost all transportation is stopped, and also all people cannot use the trains. So the many people just stuck in city center of Tokyo, the some city areas. So based on this data, we can monitor where the many people is stuck in the city areas when the heavy earthquake occur. In addition, the mobile data can detect the state point of each person, and integrate the train data or the bus stop data. We can also estimate the attribute of each state point. So using this data, we can estimate the dynamic population and the regional characteristics of the urban area, and then we can also define. We can also find the event occurrence. And this is one example. This is the estimation of the dynamic population in the commercial areas. So each color shows the estimated number of the visitors in one day in 2011. And in addition, we can also monitor the dynamic population in hourly changing population of each commercial areas like this. And this is the average number of the visitors in a weekday. And we can also find the event detection. We can detect the event. So we define the certain population concentration, spatial temporary, called the event. And the event contains the positive events and the negative events. So this is the number of the events in Japan in 2011. So you can find the many events in the January 1st and the golden. This is the special holiday season and the summer holiday season. And you can find some specific events from this chart. For example, here this is the open event on your green base of the United States Air Force. And this is the magnifier display. And in addition, we can also find the negative effect. This is the typhoon effect here. So the event matches with a small number of event visitors. So the many tourists were stuck here, these areas, due to the effect of the severe typhoon. So next I'll show you the developed disaster big data. So as you know, Japan is a disaster company, the disaster country. So the Japanese government estimates that the victims by the Tokai and Tonaka earthquake are over 300,000. So now we use the various microgrid data, the census data. We estimate the data about the earthquake damage risk and the death rate of each building. We call such kind of data the disaster building. So to integrate some kind of existing data, the microgrid data, and the earthquake motion, we can estimate the damage risk or the death rate of each building by the heavy earthquake. Now I show you the movie. This is the base data of the building. This data shows the part of the Tokyo, but this data can cover throughout Japan. And to integrate some census data and disaggregate the census data, and to integrate the earthquake motion, we can estimate the risk of each building by the heavy earthquake. Each building, the red building is the risk is very high, and the yellow middle, and the white, the gray is not so large. Based on the data, we can also estimate the disaster damage, the earthquake damage estimation throughout Japan. So now I move to the Tokyo, center of Tokyo. And this data also monitor the risk of each building. And in addition to integrate the person flow data, we can also estimate the number of the hourly casualties by the building collapse or fire in throughout Japan. This is the map shows the Tokyo metropolitan area. And this relatively received a lot of attention in Japan. So the using the media, the magazine, books, and this data also utilize the disaster drill for the citizens in some areas, some cities. So finally, I show you the utilize the public big data. Now, the local government has many precious public data, and now we start studies to resolve some concrete problems of the local government to using the various public data. So one of the severe problems of the Japanese local government is increasing the vacant house. So this is the trend of the vacant house rate, and the vacant house is not only the rural areas, not only the rural areas, but also the urban area or the residential area. Those shopping street is there are many vacant houses. So the local government want to monitor the location of the vacant houses. So now we collect some public data, so without private information. So it means the citizen names. And in some cities with the Japanese government. And now we collect the three kinds of the public data. The first one, the register information of each house. And the second is the consumption data of the city water. And the third is the property tax data. And then we can develop the estimating model of the vacant house to integrate these public data and with result of the field surveys. So for example, this house is a vacant house or not, only the picture is a bit difficult. But if this house, there are no residents by this data, and no water consumption from this data, and no taxation from this data, this house is estimated vacant house. Actually, this research project is ongoing in some Japanese cities. This is the result shows the estimated number of the vacant house in Kagoshima city here. And the red area is the many vacant houses. And our results shows there are 96 vacant houses out of about 2,000 and in the test field of the Kagoshima city. On the other hand, the result of the field survey in the test area is 94 vacant houses. So very near, very similar values. So it shows the public data is very useful. So this result was now provided for the housing and city planning sector of the Kagoshima city. So this result shows the correct of the public data is actually very difficult. This is because in terms of the personal data collection. But the public data is pinpoint data and very reliable data. So that they are very useful for the urban management and urban planning. So there is a possibility. So if the local government will provide public data, if we can show the aim and the usefulness of the public data, I think so. Okay, so now I summarize my presentation projects. So this is the conclusion. So now the article studies which are difficult before realized now. And the second is anyone can develop the environment to handle and analyze the big data, the micro data. And in addition, our approach is expected to support the policy development based on the quantitative basis. So it is expected that the data-driven policies will have purchasing power for the citizens, and the conduct of the policies based on the data will support to realize the smart city. But there are some challenges. Right? So the first one is the development of human resources. So who can handle and analyze the micro data or the big data is very important task. So we need to acquire the skill to handle and understanding of the big data and the micro data. And the second one is the integration of the micro data with the field data. It's also very interesting. I think that we need to understand the micro data or the big data is not universal. Okay? So to integrate micro data and the field data, so micro data or the big data will be used more than now, I think. And finally, the collaboration with the government sectors or smart cities, it's also very, very important. To realize the smart cities, okay, so we need to collaborate with the national or the local governments and to share our research and their tasks. So it is very important. And it is difficult to collect the useful public data. I will not show, but it is possible if our suggestion is very helpful for local government and citizens. And so finally, I show you there are some projects to develop the user environment of the big data in Japan. There are I just introduced 3 projects. First one, this is under operation. It's the region economic society analysis system, the research I have already introduced. And this is under operation, the data integration and analysis system called the DIAS. This is basically the academic use. And the third, now is under development, geospatial information center. So this is basically use the government sector or the private sector. So in near future, to develop the micro data, the user environment, and second is a collaboration with the various platforms like this, and to share the research results and tasks. They will become the very important points. Okay, thank you very much. 감사합니다.
스마트 도시와 공간 빅데이터라는 내용으로 발표해 주신 교수님께 다시 한번 큰 박수 부탁드리겠습니다.
질문 하나 드려도 괜찮습니까?
질문이요? 예.
I have a question. you.
Yes.
And it was a nice presentation.
Thank you very much.
Regarding the floating population, dynamically floating population,
Definitely, yes.
I appreciate and agree that the trends are quite intuitive. It's good. By the way, have you ever tried to check and validate the accuracy? If you did, how?
Yes, yes. So we have already checked the validation, so this is the mobile phone data, and this personal data is based on the questionnaire survey. So that this is the reliable data. So that to compare with this personal data based on the questionnaire survey with the mobile phone data in RE and the spatial employee, and the results show this data that the mobile phone data is relatively reliable. Yes.
So did you check a qualitative analysis about the correlation between the two?
So you use hourly or
Qualitative analysis.
yeah.
And the quantitative analysis.
Quantity.
Yeah.
So
About the
So
correlation.
you mean the number of the person, the number of person, you mean?
Yeah.
Yes, this is because this data is only the sample data. Okay, sample data. The Japanese population is about the 120 million, but this data is only contained 1.5 million.
Okay.
So this is the sample data.
So as a result, did you agree the mobile data is quite accurate?
This is based on the location, I think so. For example, the city center of Tokyo is relatively good, but the rural area is sample is very few, so they're not so good. The city area, the urban area is good.
Thank you.
예, 교수님께서 잠시 후에 패널 토론에 토론 패널로 참여를 하시니까요. 더 자세한 내용 그때 한번 다시 질문을 받는 걸로 하겠습니다. 다시 한번 교수님께 박수 부탁드리겠습니다.